Hello. In this worksheet, we're going to talk about gerrymandering. Year 2020 is a special year. Every 10 years, the United States does census, and that means every household is going to be given a survey where they answer a certain number of things. And data from the census is going to be used to uh, refigure out how many representatives each states get, and those state lines that, within the state, there are district lines that's going to be redrawn to accommodate for changing number of districts. And it turns out that um, being able to draw lines gives a lot of power to how the election swings in one way or the other. And this worksheet is kind of looking at the ideas of how this happens, right? So let's look at it. Okay. So what is gerrymandering? So gerrymandering is intentional redrawing of districts lines for the purpose of political gain. And it's done by manipulating the efficiency of voting districts through transfer of wasted votes between neighboring districts. So there's two main types of techniques you could do with gerrymandering. One is cracking. So cracking is trying to create a district that's almost 50-50, but the side that you want to win, it just edges over. Maybe maybe it gets 55% of the votes, and the losing side gets 45% of the votes or something. If it's a close race and one side win, there's only one representative for one district. So the losing side wastes all of that 45% of the votes that went to one of the parties. That's what cracking is. Packing is another technique. Packing is creating a district that goes to the side that you don't want to win very much, but you're doing it in such a way that it contains as much of those votes as possible. So you're creating maybe a district out of 100% of voters, maybe like 95% is going for one party, and 95% is a big win for that party, but it's actually a lot of wasted votes because you really only need 51% of the votes to get representative for that side. So if you had 95% of the votes, that's over 40% of the votes I actually kind of wasted. So you take, maybe you lose that district, but you win in other districts because you've eaten up a lot of voters for that one party. That's called packing. All right, so both of these techniques tends to concentrate wasted votes for one side. So let's say we have this rectangular states that's shown below, and there's two parties, the blue party and the red party. So in the right, there are three different types of districting that one could draw, but the result for each types of drawing is radically different. So I want you to look at it and see how many boxes. So let's say one box is one precinct, and there's 10 precincts in one district, and the majority color for each district will win a representative. So try to compute which party wins how many representatives for each of the three that's shown on the right. Maybe I can kind of show you what happens by example. So let's look at this guy right here. So the most complicated looking one. There are 5 districts. There are 2 districts right here. These 2 are the ones that the blue party wins. So blue party wins 2. And then these top 3, one that looks like a T, actually there's 2 that looks like a T, one that looks like an alien. Those goes to red party. So there's 3 representatives that goes to the red party and 2 representatives that goes to blue party, even though the original state has 40% of the voters going for red party and 60% of the votes going for the blue party. So in this gerrymandering, the number of representatives actually goes to the minority party, which is strange, right? But just by the way you draw it, you could make this happen. So you can see that the top 3 of these districts are cracked. It barely goes to the red side, and these bottom 2 districts are packed, right? So blue wins by majority, but by doing that, they're wasting a lot of votes. Right? So I want you to work out what happens with the other 2 situations and answer a few questions about what you think about them. Okay. So last year, there was a big Supreme Court decision on gerrymandering. So judicial branch of the United States have been trying to stay away from making judgments that sways politics. So they've been trying to not answer this question about gerrymandering, but it's becoming more and more apparent that drawing districts does give the drawer of the lines a lot of power and political sway. So it's becoming a topic that they must roll on. And their main pushback was, hey, it's very difficult to determine when something is gerrymandering or when something is, it just looks weird on a map, right? So they want a clear cut yes or no, like when can you determine if something has been gerrymandered or maybe it just looks weird because of the strange topography of the cities and so on. So there's been lots of different measures that's been suggested on this is how to tell if there was a gerrymandering or not. The big Supreme Court decision that happened last year was on the measure called the efficiency gap. So this is a way of measuring how much more wasted votes were there for one side of the party over the other. So what you do is first count the number of wasted votes for each party. So let's say there are 2 parties, A and B, and you count the number of votes that they didn't need to win a particular representative. And what you do is you look at the difference. So you just look at, okay, party A wasted this many votes, party B wasted this many votes, look at the difference and the absolute value, because it could be negative, right? And then you divide by the total number of votes that was cast in the state. Okay. So what I want you to do is to kind of go back for each of these 3 districts that's been shown, compute the efficiency gap for each of the state, each of the party. So let me give you an example of how this this can be computed. Let me look at the one that we've already looked at. So let's look at the blue packed district on the bottom left. Okay, so blue party won. So there were 9 votes for the blue party and 1 vote for the red party. So blue only needed 6 to actually win that representative. So blue wasted 3 and 3 because there was 9 votes that was cast, but only 6 was needed. So 3 was wasted. On the red side, there was only 1 square, so 1 vote was wasted on the red side. It was wasted because they did not win the representative they wanted. On the bottom right, this is again 9 and 1. So oops, blue side wasted 3 more, and the red side had wasted 1 more on the bottom right district. And then the top 3, the red party needed exactly 6 votes to win each of these representatives, and they didn't waste any votes. That was the exact number that they needed. But the blue party wasted 4 votes for each of those 3 districts. So wasted 12 more, and red wasted no more. So the total number wasted on the blue side is 18, and total wasted on the red side was just 2 total. Okay, so looking at the formula, so the efficiency gap for the third districting was wasted number for A side is 2 minus the B side is 18, all divided by the total number of votes. So let's see, there were 50 squares, 50 votes total. So 2 minus 18 is negative 16, but absolute value makes it 16 over 50. So that's 32%. Okay, which as far as gerrymandering goes, 30% is off the charts. Usually efficiency gap should be a single digit percent, like somewhere between -5 to 5% is a regular efficiency gap. If it's going to 2 digits, there's definite manipulation going on. It's difficult for that to happen just by chance. And going to 20 or 30 is incredibly wasteful for one side over the other. So I want you to look at the efficiency gap for these 2 types of districting as well. So try to pause this video and see if you can compute it. Okay. And here's a exercise on trying to draw the map for yourself. So let's say red and blue are their voters, and it's kind of randomly mixed together. But I want you to do is I want you to swing the representative on one side or the other. So on the first one, you want the district so that the red wins 4 out of 5. In the middle one, I want you to do red wins 5 out of 5 districts. And on the last map, I want you to draw so that the blue wins. So this one, Red is the majority, but I want you to flip it. 3 out of 5 in this case. So maybe I'll do one and maybe you do two, just so you can see what happens. So I want the red to win 4 out of 5. Okay, so I'm gonna have one. Let's see, one district that goes to blue. I'm just gonna draw it here. So I'm trying to pack it, right? So I'm trying to look at the situation where 4 out of the 5 is going to blue. So blue wins 1. Okay, I want the red to win the rest. So let's see. Okay, so maybe that's one. Maybe that's one. Maybe that's one. Maybe that's a district. So there's 5 different districts with 5 square each. And red is the majority in 4 out of the 5. So there's many different ways to do this. So that's one way to draw a district. So red wins 4 out of the 5 districts. Let's just kind of count the number of wasted votes. So on the blue side, how many votes are wasted? So in a district of 5 squares, you only need 3 to win each of the sides. So let's see. When there's 4 out of 5, there's only 1 wasted in the district, the blue one. Here 1 is wasted. Here's 2 is wasted, and here 2 is wasted. So 1, 2, 3, 4, 5, 6 wasted total. Okay, the number of wasted votes for red. So that's 1 here. You only need 3 to win, so there's 1 wasted here. No wasted in these 2. And then 2 wasted here. So 2, 3, 4. 4 total. Okay, so efficiency gap is 6 minus 4 divided by the total number of votes was 20. So 2 over 20 is 0.1 or 10% is the efficiency gap here. Okay, so what I want you to do is try to figure out a way for a red party to win all 5 districts. That one's a little bit difficult, and also trying to come up with a district where blue as a minority wins 3 out of 5. That's also difficult. So try to see if you can find it. There's a couple of solutions that's possible, but it is pretty challenging. So try it out, and as you do it, see how the efficiency gap rises as you gerrymander these things. Okay. All right. And I kind of want to leave you with an open question. So these are pictures of like actual boundaries that's used today that is gerrymandered. So it's not just for one party. Both parties do it. So it is in the interest for everyone to have this type of abuse end, right? It's ridiculous to have a situation where the person who has the decision power gets to decide how they themselves get elected, and even have a say in have even more power as a result of drawing districts. So I want to give this question to you. The Supreme Court did decide that this efficiency gap was not a good measure for measuring how something is gerrymandered. Can you come up with a way to measure it that's intuitively easy to understand? Because these Supreme Court justices, these are brilliant people. They're very smart, but they're not math majors, right? So they're not specifically trained to do statistics or mathematics. So is there a way to come up with a mathematical measure that's clear that one side is being swayed, but that's not too complicated, right? It's an open problem because it's we don't know if there's a good answer for it. I think the efficiency gap was a pretty good measure, but Supreme Court didn't agree. So I'm hoping that you guys could come up with a better measure and then present it in front of the Supreme Court. So maybe they could say, yes, that's a good way to measure it. This is mathematics that really does affect our lives. So I hope you found this interesting, and I will see you in another video.